Today we are going to learn how to solve systems with elimination. So far you have learned how to solve systems by graphing, where you graph two lines and where you find where the lines intersect. You have also learned how to solve systems by substitution. Where you plug in an isolated variable. So you take this y out and you replace it with 3x minus 6. And then you continue to solve. Graphing is a great way to solve if you have two equations that are easy to graph. Substitution is a great way to solve if you have an isolated variable or a variable alone. Today we are going to learn how to solve with elimination. In order to solve with elimination, both equations must be in standard form. For example, 2x minus 3y equals 10, 4x plus 6y equals 8. Standard form means your x comes first, then your y, and it equals your number. Your x comes first, then your y, and it equals your number. In order to solve with elimination, this is the easiest way to do it if it is in standard form for both equations. In order to solve with elimination, your goal is to get one of the variables to eliminate or cancel as you add down. If you look at your first example, what you will notice is that if you added straight down, your x's would cancel. If that is the case, it's a very easy problem. You just add down, x and plus negative x cancel, 3y plus 2y is 5y, and 17 plus 8 is 25. Once you get one of your variables to cancel, you can next divide by 5, and you have your first solution, y equals 5. Once you get one of your variables, you then pick either the top or bottom equation and plug in your value for y. I'm going to pick my top equation. So I keep my x. I plug 5 in for my y. 3 times 5 is 15, and that equals 17. I then solve by subtracting 15, and x equals 2. So my solution to this problem is 2, 5. We will try one more example like that one. If you look at example number 2, if you notice, this time the x's do not cancel, but the y's do. So it does not matter which variable cancels, as long as one of them does. So now if I add down, I get 4x minus x, which is 3x, 3y plus a negative 3y cancel, and 6 plus 3 is 9. Once I get to that point, I can then divide by 3, and my x value is 3. Once I get x, I can go up here and plug it into the top or the bottom equation. I'm going to choose the top equation. I plug 3 in for x. 4 plus 3 is 12, plus 3y equals 6. Once I plug it in, I solve for y by subtracting 12. And once I subtract 12 from both sides, I now have 3y equals negative 6. I divide by 3, and y is equal to negative 2. So if I write it as a coordinate, my solution here is 3, negative 2. If you want to make sure you are doing them correctly, you can always take your points and plug them into the other equation and make sure that you are getting this equation to be true with your solution. Okay? So now we are going to go to example number 3. On number 3, what you will notice is that neither your x's or your y's cancel. If that is the case, you must multiply either the top equation or the bottom equation or both equations by a number to get them to cancel. If you look at number 3, what you will notice is that they both are 5x. But in order to cancel each other, we need one of them to be a negative. So I could either multiply the top or the bottom by negative 1, and then my x's would cancel. I am choosing to multiply the top by -1. When I multiply the top by -1, I must multiply that -1 through to all pieces. So I end up with a -5x, a -2y equals a +28. Once I do that, I've replaced this top equation with a new equation, and then I do it the exact same way. So I add going down. So if I add going down, my two x's cancel. A -3y plus a -2y is a -5y, and a -8 plus 28 is 20. Once I do that, I can now divide by -5, and once I divide by -5, I get my y value. Once you get your y value, you have a lot of choices to plug it back in. You may plug it back into your top, the bottom one, or the new one you made. I'm going to choose to plug it back into my top equation. So I keep my 5x, I plug in -4, 2 times -4 is a -8, and that equals a -28. I add 8 to both sides. I have 5x equals -20. I divide by 5, and I get x equal to -4. So for this problem, my solution would be -4, -4. If you look at the next example, the first problem I see is that it is no longer written in standard form. So the first thing we must do is actually get them both into standard form. The top one is written perfectly in standard form, so I'm just going to take a minute and rewrite that one. But the bottom one needs to be written in standard form. My 3x is on the correct side, so I'm going to leave him. I'm going to bring my y over by subtracting y. So then I will get 3x minus y minus 18 equals 0. But then my next issue is the 18 is on the wrong side. So I must add 18 to get that guy to the other side. So my final answer is now 3x minus y equals 18. Once I have written him in standard form, then I can easily compare to see whether my x's or y's cancel. In this case, my y's cancel exactly as it's written. So I have 5x, my y's cancel, 12 plus 18 is 30, I divide by 5, and I get x to be 6. At that point in time, I can plug it into my equations. I'm going to pick my top equation, and I'm going to go 2 times 6 plus y equals 12. 2 times 6 is 12. If I continue to solve this by subtracting the 12, you will see that y equals 0. So my solution here is 6, 0. And that is how you do question number 4. We are going to skip 5 and 6, and we are going to jump to number 7. What you will quickly notice on number 7 is that they are both in standard form. However, my x's do not cancel or my y's do not cancel. And there is not an easy number like -1 to get either one to cancel. There are many different ways of doing this problem. If you are having a hard time figuring out how to get either x or y's to cancel, there is a shortcut way of doing this. First of all, you must decide whether or not you want your x's to cancel or your y's to cancel. Let's say we wanted our x's to cancel. The quick way of doing it, if you cannot see numbers right away to multiply either the top, bottom, or both by, is you take the number on the bottom in front of the x and put it out front on the top, and you take the number on the top in front of the x and put it out front in the bottom. Once you take those two numbers, you then have to decide whether or not, if you multiplied these through, if your x's would cancel. -4 times a -3 is a positive 12. -3 times a -4 is also a positive 12. Because they are both positive, If I left it this way, they would not cancel. So if that is the case, then you go back and change one of their signs. So instead of multiplying this by a -4, I'm going to multiply it by a +4. So now when I distribute, I get a -12x, -20y equals -28. On the bottom, I keep my -3. -3 times a -4 is a +12x. -3 times a -3 is a +9y. And a -3 times a -2 is a +6. Now if I were to add down, my x's will cancel. -20 plus 9 is a -11y. And -28 plus 6 is a -22. Then I divide by a -11, and I get y equal to 2. At that point in time, you could plug your answer into the top equation, the bottom equation, or either of your two new equations. I'm going to pick my top equation, and I'm going to plug in 2 for y. So I have a -3x. If I plug in 2 right here, -5 times 2 is a -10, and that equals a -7. I am then going to add 10. I have a -3x equals 3. I divide by a -3, and I get x equal to -1. So my solution to this problem is -1, 2. Okay, for the next example. This one is very similar to question number 7. If you look at it, if you notice, your x's do not cancel, nor do your y's cancel. If you cannot just visibly see numbers to multiply to get them to cancel, the quickest way is to pick a variable and then put those coefficients out front of the variable outside on the other line. For example, if I chose to get my x's to cancel, I would take this 5, write it out front here. I would take that 8 and write it out front there. Now I have 40x here and 40x here. Because they are both positive, I then need to go back and make one of my numbers out front negative to get them to cancel. I'm going to choose to change my top 5 to a -5. Now when I distribute, I get a -40x plus 15y equals 45. When I distribute on the bottom, I get a positive 40x plus 32y, and 8 times 12. If you need your calculators for some of these bigger values, that's fine. 8 times 12 should give you a value of 96. Now when I add down, my x's will cancel. 15 plus 32 is 47y. And 45 plus 96 is 141. I can then divide by 47, and y will equal a value of 3. Once I get y, I can plug it into my top one, my bottom one, or either of my two new ones. I'm going to choose to plug it into my top.